Hello. Now, we're going to continue on with our work in groups. And now that we've defined what groups are in maths, we're going to call them sets. And we know that they're a well-defined group, or we know exactly what the members of that group are going to be. That was what we looked at before. Now we're going to talk about the members of our group, or in maths speak, the elements. Elements is going to be the name for members of our group, of our set. So the members of our group will be called the elements of our set. So that's our language. We have the members of our group, and we can picture lots of groups like our immediate family or our class or our school. We all know that they're well-defined groups. And then we have our members of our groups are going to be called elements. So in maths, our name for our members of our group is going to be elements, and we're going to use a symbol for it. It looks a little bit like the letter E. We effectively just draw the letter C and put a line through it. And that's our maths way of writing the word element. So in maths, again, we're always going to be using abbreviations. We're going to shorten things down so we don't have to write so much English. And in this case, we're learning a new word, and we're also learning a new way to write it. So element is the name for a member of a group, and we are going to use our C with a line through it to write the word element, so we don't have to write the English word over and over again. So that's all of our definition work done right now. So let's have a look at how we would implement that. So if I wanted to know about the member of our group here, so is L a member of the group C? Let's go back to what our group C, our set C, was about. It was the letters in the word class. So translating fully into English, is L a letter in the word class? And we all know that it is. Excellent. Now let's translate it gradually into maths. So is L an element of the set C? That means the same thing as the first way I wrote it. And this is it translated into mathematical language. Is L element set C? And let's go up to our list. We have it written on the page. So never try and do this from memory. Actually write out the elements of the set if you're asked a question like this, so that you can clearly see whether an element is or isn't in the group, isn't in the set. So in this case, we can see L is a member of our group. So we can say either that is true, L is an element of the set C. So L is an element of C, the set C, which is the letters in the word class. And that's true. So this is our way of writing our answer. This is true. L is an element of C. And you can see how much shorter that is to write than our big long English sentence. Now let's have a look at another question which I've just written in mathematics. Is 6 an element of the set A? Well, let's go back up. Our set A was our natural numbers, our positive whole numbers from 1 up to 5. And we have our list of A. We've done our curly brackets, 1, 2, 3, 4, 5, with our commas in between, close curly bracket. Is 6 one of the things written in that set? And it is not. So we would say that that is false. I should have a question mark there. That's false. That's false. And how are we going to write this? Well, if we write something down like this, that wouldn't be true. 6 is not an element of A. So how are we going to write down is not for our element? So to say that it's not a member of the group. Well, if we write something down that's wrong and we don't have anything to erase it with, what do we often do? We'll put a line through it. We know that it's when we're writing something down and we make a mistake and we don't have Tipp-Ex or a rubber with us, we're just going to put a line through it. So 6 is not an element of the set A. Or translating back into English, 6 is not one of the whole numbers from 1 to 5. So that's our idea of members of a group. Is something an element of a set or not an element of a set? If it is an element of a set, we can write down L as an element of C as an example, or we could have a situation in where an element is not a member of a set, so we would say 6 is not an element of A in that case. So that's our idea of members of a group, and we know now that we're going to call that elements of a set. Our next idea is how many members are there in our group? How many people are there in our group? How many objects are there in our group? And that is going to be called the cardinal number of our set. And it has a symbol that all of us are going to be familiar with. It's the hashtag symbol. So we have the number of elements in a set, the number of people in our group, or the number of members of our group. The number of elements in the set is going to be called the cardinal number. Now it's important we get this by counting up the number of elements in the set. So it's not going to be a set, and that's going to come back to be important in just a moment. Now let's take an example from our sets that we've already got here. How many days is in a week? Now that was one of our effectively one of our sets from before. The days in the week was the set D. So if we translate that partly into maths, that would be how many elements in the set D, the days of the week. And remember, each day was an element of that set. So how many days in a week is the same as asking how many elements is in the set D. And writing that in mathematical language, you can see how much shorter it is. We have hashtag D. The cardinal number of D is how we would say that in maths, and we need to know that our hashtag symbol is called cardinal number. This is important. So we have the cardinal number of D is a fully mathematically formed sentence instead of this English sentence, how many days is in a week. So cardinal number of D, well, that's just how many elements there are in the set D. So we have them written out here on the page. If we didn't, we would write them out to make sure that we didn't make a mistake. And we have 1, 2, 3, 4, 5, 6, 7 days in the week. So we'd have the cardinal number of D is going to be 7. Now there's no curly brackets here. Why? Because this isn't a set. There are 7 days in the week. This is the number 7 from counting up the number of elements in the set. It's not a set itself. So the cardinal number of a set is just a number we get from counting up the elements in a set. Now let's take another example. What would be the cardinal number of the set C? Well, let's write out. We're always going to write out exactly what we're answering. Cardinal number of the set C is going to be equal to what? Well, let's go back to the set C. It's the letters in the word class. So I write out my elements of my set in my curly brackets with a comma in between. And I'm careful that I only write each element once. So I can again see I have S is only written once when I'm listing out my elements. So I have C, L, A, S. And I remember that the order doesn't matter, so I could also write down S, C, L, A if I wanted to. The order doesn't matter, but it does matter that we only write each element once. So if I have S, C, L, A, I have 1, 2, 3, 4 elements in my set. So the cardinal number of C is going to be 4 because there are 4 elements in my set. And that's what we need in order to be able to solve our problems now. We now know about how we can talk about the members of our group. We use the word element, and we use our symbol here for the elements of our set when we're writing mathematically. And we know how to write if an element is a member of a set and if it is not an element of a set. And we also now know the short way, the mathematical way of writing how many elements there are in a set, and we call that the cardinal number. And if we have those tools, we can start to do more interesting things with our groups.